So this is your video lesson for topic 5, solving quadratics by factoring. This is a part of your geometry algebraic unit. So we start off with the zero product property. We're going to use that a lot in this lesson. It says that if A times B equals 0, then A must equal 0 or B must equal 0, which should make sense because anything times 0 equals 0. This is true for numbers, but it's also true for expressions. So say we have the expression x times x plus 1 equals 0. Then again, that must mean that if x is our A, that must mean that x can equal 0, because if x is 0, it's just going to make the whole thing equal 0. It also means that x plus 1 will have to equal 0. And when you solve that equation, it gets you your other solution. So let's try that here. For 1, 2, and 3, these are already factored for us. So identify A and B. Okay, so your A is x minus 3. We're going to set that equal to 0, and then set your B equal to 0 as well. Add 3 to both sides. So x equals 3. Subtract 12 from both sides. X equals negative 12. So notice that we get two solutions for these equations. Number 2, our A is negative 4x, and our B is 2x minus 3, so we're going to set both those equal to 0. Add 3 to both sides. Divide by 2. Okay, so for the third one, there are 3 parts of this, including the 11. Notice that the 11 is not attached to any variables. That means it's not going to give us any solutions. So we just have the 7x plus 1 and the x plus 3 that are going to give us solutions. Set those equal to 0 and solve both of those equations. Feel free to pause the video if this is ever going too fast for you. All right, so below you have 3 problems to try on your own, so please try 4, 5, and 6. Pause the video, try those problems, and then we'll move on. All right, so here are your solutions. For 4 and 5, here's the work and the solutions. Pause the video if you need to. And here's number 6. All right, so solving quadratics by factoring. So now it may not be factored for us. We're going to have to do that. So you could factor it maybe by using the GCF, or if it's a difference of squares, or you may have to factor it into 2 binomials. You want to set each factor equal to 0 once it's factored, and then solve those equations that are equal to 0. So number 7, we have a squared plus 6a plus 8 equals 0. We do not have a GCF, and we have 3 terms, so that means we're going to break it apart into 2 binomials. We need an a times a to get the a squared. Then we have to multiply to 8. That's 1 times 8, or it could be 4 times 2. To pick which one we need to use here, well, then we use the 6. We need to find the 2 numbers that will add to 6. So that's going to be the 4 and the 2. All right, now that's factored, set your factors equal to 0. Subtract 4 and you get negative 4. Subtract 2 and you get negative 2. Number 8, so again, there's no GCF. There's only 2 terms this time, but notice that both of these terms are perfect squares. So that means we're going to be able to break it apart into 2 binomials. B times B gets you the B squared, and then 5 times 5 gives you 25. Now we need them to be opposite signs so that the middle term is canceled out. Now set them both equal to 0. Subtract 5. Over here, add 5. Number 9. All right, first look for a GCF. This one does have one. Our GCF is 2x. So we're going to factor out 2x. To determine what's left inside the parentheses, we need to divide both those by 2x. So 4x squared divided by 2x is 2x, and then 6x divided by 2x is 3. Now you have your a and b, set them both equal to 0. divide by 2, and you just get 0. Add 3, divide by 2, x equals 3 over 2. So pause the video now, and we're going to try some problems. So go ahead and try 10, 11, and 12 on your own. Try 10, 11, and 12 when pausing the video. Here are your solutions for 10 and 11. And here's your solution for 12. All right, so moving on. So exploration 1, consider the following quadratic function, f of x equals x squared minus 3x minus 4. It says to set each output equal to 0 and solve for the input variable. Well, the input variable is just x, and the output variable is y, or f of x. So that's what you get when you plug in a number for x. Okay, but we know that we want our output to equal 0, so that means we're going to set that equal to 0. So x squared minus 3x minus 4 equals 0. Let's go ahead and factor it so that we can solve it. To multiply to 4, we have 1 times 4 and 2 times 2. But 1 times 4 is going to work better because we have to get a negative 3 in the middle. In order to get a negative 3, when we add them, the 4 will have to be negative and the 1 will have to be positive. Set these both equal to 0. So when you solve x plus 1 equals 0, you get negative 1. And when you solve x minus 4 equals 0, you get positive 4. All right, use a graphing utility to sketch the function. So I have that up here. If you graph x squared minus 3x minus 4, notice that it has the x-intercepts of negative 1 and 4, and it's a parabola that opens upwards. That's the same thing. So we got these solutions, x equals 1 and x equals 4. Those are our x-intercepts. This parabola is opening upward because it's a positive coefficient of 1. So we just found those steps here. We want to plot the x-intercepts, sketch a U-shaped graph that opens upward if a is greater than 0. So our a was greater than 0. And then it opens downward if a is less than 0. So your x-intercepts, that's what you're finding when you're solving an equation. Those are the real solutions that you get, or the zeros or the roots. They kind of all mean the same thing. Okay, so same idea here. So we're going to set it equal to 0. Break apart your factors by setting them equal to 0 and solving. Divide by negative 2, that's just 0. Add 3. So now what we know as this pertains to the graph is that we have x-intercepts at 0 and 3. But go back and look at that value of a. That's a negative 2. That means a is less than 0. And our parabola is going to open downward. So just do a quick sketch. Okay, so now solving equations by factoring when terms are on different sides. So if it's not equal to 0, then just use your inverse operations to move things around so that it is equal to 0. So for number 13, w squared minus w equals 42. All we have to do is subtract that 42 over. There's no like terms, so you just subtract it on there, and then factor it. So now it's equal to 0. We can use 7 times 6. So 7 times 6 is 42. And if you do a negative 7 plus, if you do a negative 7 plus 6, you get that negative 1 in the middle. All right. Okay, so same idea here. It's not equal to 0. Let's move the 3x over and the negative 2 over. That's a positive 3x, so go ahead and subtract that. And then we have that negative 2 left. So let's go ahead and add that over. Now it's equal to 0. So we can go ahead and factor. We have to multiply to 7, so that's 7 times 1, and 7 plus 1 is 8, so it all works out. Set them both equal to 0. Minus 7 Subtract 1. Okay, get your two solutions. So go ahead and try 16, 17, 18. Pause the video here and try those problems. All right, here are those solutions for 16, 17, and 18. Our last two problems, we're just going to practice a little bit of what we just learned. So we're going to use this to sketch the graph. In order to sketch the graph, we're going to use the x-intercepts. And remember, when we find the x-intercepts, we're setting the equation equal to 0. It's already factored for us. So take each factor and set it equal to 0. Subtract 1. So now let's use that. We have a solution at 0 and -1. Notice that's a -3. It's going to open downward and pass through those x-intercepts. All right, same idea here. Let's find those x-intercepts by setting it equal to 0. Now we can factor. We need to multiply to 5. That's 5 times 1, and 5 plus 1 is 6. When you set them both equal to 0, you get x equals -5 and x equals -1. So -1, -5. We have a positive a value. It's a 1 in front. So that means that this guy is going to open upward.